Hello, Mile High Video, and welcome to my session on Common Media Client Data. My name's Will Law and I work here at Akamai. I actually want to start my talk by taking us back to last year, to Mile High Video 2019. I had given a talk about player optimizations, and during that talk I suggested that players could communicate with CDNs while they were requesting media and convey some useful information. And then in the Q&A session afterwards, we'll jump into David Hussain asking a question in this regard.
From the CDNs in regards to attention to the players and also the CDNs are super valuable. But one of the ways that is reality now in the multi-CDN world that we live in is that we need kind of communication across that from different CDNs. Have you seen that been taking place? Have you guys been initiating that in any way so that the same headers can be used or are being used by all the different CDNs to have this type of heading control?
Yeah, that's a great question. So every CDN has some different idea. I think this is an excellent candidate for somebody like the SVA. Jason's listening. Yes, he is. To standardize this, there's no benefit that we don't want proprietary Akamai headers, and we don't want fast. You want your players sending Fastly headers, Akamai headers, Limelight headers. Let's all agree on some useful names and standardize them. The question would be where to do it, and it's not a dash, it's not an HLS. And it's not a W3C initiative. So we need some external body to standardize it. But that's more a process-oriented problem. I think the industry community, which is really coming together for video a lot more now, this should be something we should be addressing. And we don't have to overcomplicate it. A simple set of headers and a one-page definition, and it's far more likely to be implemented widely than buried down in some 100-page doc somewhere. So I'll support that, and if anyone's interested in collaborating with us, come speak to me.
Well, despite my bad hair day there, it turns out we did get some support. So I'm happy to announce that the group who took on this project was CTA and their Wave project. We got a number of notable companies to join us in this effort. And 9 months later, which is very fast for a spec, we actually have CTA 5004 Common Media Client Data. So it's a success story essentially from Mile High Video, getting a group of people together, a common forum from which we can say we need a solution and driving us forward. But I want to start examining what problems CMCD is actually addressing. So let's look at this from the point of view of CDN logs. Here's an animation of some CDN logs. Now this is flowing too fast for you to read, but that's not the point. In fact, our logs come in 66 million log lines per second. But they're all independent. We don't know if they're the same player or different players, or where one playback session begins and another playback session ends. For example, if we see these log lines all coming in with the same client IP and the request for media segment, I don't know if these ones over here are different clients that are natted behind a mobile gateway, or in fact it's the same client that is falsely requesting segment 47 twice. We can't tell. On the QoE side, in other words, on the player metric side, you dimension or you slice your data according to playback sessions. I start playing a certain video, I end playing it. But on the CDN side, we only see hits, independent requests for binary objects, and it's somewhat disconnected from the notion of media. For example, here might be a CDN logline requesting segment 3246.m4s. I will challenge you then to answer these questions. Is this a 2-second or a 6-second media segment? Is this HLS or dash? Is this player at startup or is it at steady state with a 30-second buffer? What is the bitrate of this object being requested? Is this a video segment or an audio segment? Is it a live stream or a VOD stream? Is this player healthy or is it rebuffering? And if we as a CDN spend 1,200 milliseconds delivering this segment, are we doing a good job, an average job, or a terrible job? We just can't tell by looking at CDN logs alone. And from the other side, from the player's side, players might say, well, why doesn't the CDN know there's poor performance in a certain network before I do? Customers do not like it when they call us up and say, our players are rebuffering in Dallas tonight. Why don't you guys know that? Well, we're still seeing hits. How do we know that those hits are not, in fact, the hits associated with good playback performance? Very difficult to tell on our part. How do people tie together, if you're a player provider, how do you tie the QoE metrics that you're getting from Conviva, Nice People at Work, Mux, Akamai Media Analytics? How do you tie that to your CDN logs? They're somewhat decoupled today. How do you consistently inform all the CDNs that you want to prefetch the next media segment? Prefetching is one of the best things we can do for segment delivery optimization, yet we don't have a consistent language to tell a CDN how to prefetch the next object. How do I dimension my CDN logs by format, by live or versus VOD? People come to us and say, well, how much HLS or dash traffic do you have? Again, very difficult for us to tell because it's very hard to slice it when we're only seeing hits on the server side. Is it playlists, init segments, audio segments, video segments that are being delivered slowly by my CDN? It's often just one of these that holds playback, but it's very difficult to tell when we're looking at hits. And again, if we tell you there's 23,000 hits, you can't tell if that's 10, 100, or 10,000 videos that were actually played. So there's really a need for players and CDNs to be able to exchange mutually beneficial information. How can we do it? Well, as I pointed out, they're already communicating with one another. Every few seconds, a player is going to request an audio or video segment or a playlist update from a CDN. So while it's doing it, it can append on query data or a custom header data. So we have existing mechanisms on the web. We don't need to invent something new here to exchange information from a client that is requesting something from a server. So what is common media client data then? Well, it's a defined set of structured key value pairs that communicate mutually beneficial media-related information from a player to a CDN via one of a set of custom headers, a query object, or a JSON object. And they're common because they share the same data structure and they can be used across all players and all CDNs. So I want to go through them. In my aspirational talk, I thought it would be a one-pager. Well, it turned out to be a four-pager, but even that is not extremely long. So to give you a flavor of the information we're communicating, let's just take a quick look at it. And I'm not going to go into the details of all of them. Encoded bitrate. This is literally the encoded bitrate of the audio-video object that's being requested. Very useful on the CDN side. We get some sense of how large the object is. Buffer length of the player. This represents the health of the player to a CDN, and we can know whether players are healthy or struggling by looking at the length of their buffer. And while we might not care about individual players, we can look at what a normal range is for players at this time of day for this provider with this content, and then we can set alerts and threshold to see if the buffer length is out of normal variance. Buffer starvation. This is an explicit flag or signal where the player is telling the CDN, hey, since the last time I requested a media object, I've actually had a rebuffer event. So we get explicit signals to say the players are buffering rather than trying to infer this mystically by interpreting the log lines. Content ID, this is a string that enables the player provider to represent a piece of content. Why? Well, because many times how the content's encoded causes playback problems. So if you see a rash of playback problems come and they're all associated with one piece of content and not another, that's a very useful way to track it back. But if you don't know the content ID concisely, then it's difficult to assign that fault. Object duration, again, this is the playback duration of the object being requested. So does the video represent 2 seconds of media playback time or 6 seconds of media playback time? That affects the CDN. We want to know how much time we have to try alternate routes or alternate origins in an attempt to retrieve this object. Deadline is somewhat similar to object duration. It's the player explicitly saying, I need this in the next 5,000 milliseconds or else I'm going to be in trouble. Measured throughput is the throughput that the client is estimating. Now on the server side, we can try to estimate the pipe size or the throughput we have, the bandwidth we have between the server and the client, but it's very useful for the player to actually tell us what it's measuring, because many times what we estimate and what the player is estimating are very different values. Next object request, next range request. These are ways in which the player can hint to the CDN what is the next object that it's about to fetch. The CDN can prefetch this object, pull it to the edge from the origin, which is usually a longer journey, so that it's there and can be delivered immediately when the player next requests it. Object type, this just classifies adaptive segmented media objects by some very common types, including cryptographic keys, caption subtitles, init segments, etc. Playback rate, in the realm of low latency now, we can accelerate or decelerate playback to try to catch up. And again, it's useful to know, is this player constantly accelerating in an effort to catch up or decelerating? Maximum requested throughput is where the player can optionally choose to limit the throughput that is being sent to it. It might do this because it's never in a community's best interest to over-deliver individual streams. So instead of delivering a 3 meg stream at 60 megabits per second, we could deliver it at 20 megabits per second, throttle the delivery essentially, and the player would still be just fine and fill up its buffer just as fast. The excess capacity could then be given to other sessions that are parallel to that session. Streaming format is basically dash HLS or other, allows us to categorize and apply that dimension in the CDN logs. And then probably one of the most important of all, which is session ID. So this is a notion, this is a random GUID. It does not repeat, okay, but it identifies a given playback session and it ties together all the independent requests that might happen or be spawned by that session. There could be hundreds or thousands of media objects requested, all to play back one 2-hour VOD movie, for example. Stream type just tells us if it's live or VOD. With generic caching systems, it's actually quite difficult to tell this. Startup is a flag that tells the CDN, hey, I am either starting up playback or I'm switching or I'm recovering from a buffer empty. What's different from what's common to all of those scenarios is the player needs it really quickly. It's trying to load data faster than it's playing it back in order that it can build its buffer. So as a CDN, we might want to apply some special sauce or do something that we wouldn't do for all media segments, but we would certainly like to optimize the segments at the start of playback. So here's an explicit way for the player to tell us that it's starting up, and we might improve performance just for that startup segment. Top bitrate. This is a matching metric to the encoded bitrate. It's telling us where in the bitrate stack this player currently is. And notice this top bitrate is not the maximum advertised in the playlist. It's the maximum the player could play at that period of time. Perhaps there's size constraints or orientation constraints. But it gives us an idea of where the player would like to be versus where it is. And then lastly, a version tag, just so that we can increment this in the future and modify, delete it, and not have backward breaking implementations. So that's it. That's the sum of all the metrics that are delivered. Some basic rules then for how we configure these, and I'm just going over the basic ones here. Firstly, all keys are optional. You don't need to send anything, actually. The only thing we recommend that you send, and that is even a recommendation, is to send the session ID, because that is really useful. It ties together your QoE logs with your server logs, and if you do nothing else, just doing that gets you wins on both sides. You can invent your own key name. So if you want to communicate something that's not one of the reserved key value pairs, you can make up your own. We ask that you use a reverse DNS syntax to avoid key collisions in the future, but you can invent a unique key that you send to your favorite CDN or CDNs in a multi-CDN world, and you can recover it from your logs later. So it's a useful method of piggybacking on top of CMCD to carry information that perhaps not all players communicate, but your players want to communicate. Now, if headers are used for data transmission, originally we thought we had put them in one header, but when we looked at it, because of HPAC and QPAC, as we move to H2 and H3, dictionaries are built of the headers. So the more entropy there is in the header, or the higher the cardinality of the header, we start to blow up those dictionary and those lookup tables. So what we've done is define 4 headers, each of which carries keys which we expect to vary within a certain level of variability. So keys which will be constant throughout the session are carried in the session header because it's invariant and you can store it in the dictionary and therefore make more efficient header comparison. At the other end is CMC-request header. These are values which will vary with every single request. So there's 4 headers instead of 1 for common media client data. Now, what do these look like crossing the wire? Well, there's a duality here. The headers, as you might expect, here are the 4 headers carrying information: measured throughput, bitrate, duration, object type, CMC session ID. That's what they look like if they carried headers. They might also look like this as a query arg. The query arg, the key value pairs are concatenated and then URL encoded for transmission. And then lastly, JSON. This is also pretty readable and looks a lot like the headers. But it's very easy to convert from one format to the 2. And again, these are existing web technologies and standards. We're not really inventing anything new in how we package and transmit the data. So what useful things can you do? People ask me this. So you can read faster than I can, but I'll just highlight some from this list. So the first thing you can do is use session ID to tie your QoE logs to your CDN logs, tie them together. You can answer questions like, how many bytes do I serve per session? You don't actually really know that. You get a list from your CDN saying I delivered so many petabytes of data, but you don't know how much a particular asset necessarily takes. Excuse me. You know, is my time to first byte different for HLS versus Dash? Do I have different variances in geolocation by format? Are certain server IPs buffering more than others? Does the CDN serve small objects with less reliability than larger objects? Are my players sensitive to time to first byte? In other words, I get more rebuffer events when I know my time to first byte is lower. Can I prioritize segments at startup and switching? And can I get real-time data on my CDN delivery health by tying my CDN logs into a real-time analytics solution? And that's what I'm going to demo later in this talk, because it's one of the best features of CMCD. Now, we did actually, anytime you're transmitting data, you need to worry about both security and privacy. And of those 9 months, we probably spent 4 of the months debating security and privacy issues. So the spec was developed using existing web conventions. So it's protected by the generalized web security model. So HTTPS is recommended for transmission. And we're using query args and headers, which are well understood and well defined across the web ecosystem. In terms of privacy, there's no PII that's transmitted, personally identifiable information. We used to have a characteristic called device ID that was in fact removed for PII concerns, along with any persistent information. So there's nothing that's actually persisting between sessions. Your session identifiers are randomly assigned at the start of the session and will never repeat. The next object request and next range request are actually relative paths. So you can't use it as an attack vector by putting in a third-party URL in there and basically amplifying your attack. It has to be relative to the path of what you're requesting. And all requests to the server are optionally executed by the server. So the server is not compelled to act upon anything that you send it. And the reason for this is the server is allowed to protect itself. If it decides you are part of a rate-based attack or it doesn't like what you're asking it to do, it doesn't need to do it. So your playback should never depend, say, for example, on a prefetch taking place. It's an optional enhancement. The player asks for it, and the CDN, assuming all is good, will execute on it. I mentioned the session IDs are GUID. And then lastly, certain of our metrics like the throughput, the maximum throughput, the deadline, and the buffer length are all bucketed to within 100 milliseconds or 100 kilobits per second to reduce the fingerprinting surface. Because there might be an attack for fingerprinting where you can you can identify players by how much throughput they have. There's certainly variability in these metrics already, but just to double down on the privacy side, we decided to bucket them a little bit. So without further ado, I want to show you a demo. And the demo I have in mind is exactly the use case I was describing. So I'm going to start here. I'm on a web browser, and I'm going to launch 2 media players playing at the same time and look at the log lines from the same. My public IP is consistent. So normally these log lines would be absolutely mixed up on Akamai and I couldn't tell apart. I've chosen a low latency player. This one's dash.js. I'm just showing you the JavaScript on the setup side. It's very simple. You simply turn CMCD on as a property and the player takes care of everything else. And I'm playing a low latency stream here. I've set it to a 2-second end-to-end target latency and I have unthrottled bandwidth. So I'll start it playing back. The stream will start to play. And then over on the network panel on the right-hand side, I can click on one of the sessions and I notice that my query arg has been headed. Now, MSE-based player is going to use query args because custom headers would require a pre-flight options request with every single media segment. We don't want that. Notice that Chrome breaks out the query string args very nicely for us, decodes them so we can check them in real time. And that's a nice feature within Chrome. Now I'm going to open up a parallel player. In this case, I'm just using the standard -js reference, not in low latency mode, but I have gone in, again, it has a property. You can just turn on CMCD and it will run. And I'm playing that same live stream. This time, however, I'm throttling this player to 2 megabits per second. So you can notice it's only going to pay the 360p stream, whereas the other player had already switched up to the 720. And if we go down, we can also validate on the right-hand side here that we're getting the same query args carrying our CMCD keys. So we've got 2 players running now. I've just started them up. Now Akamai has a solution called DataStream that feeds these logs out in real time. And I think all CDNs today we're moving towards close to real-time log delivery. So notice automatically on the left that I have 2 session IDs there. I can see both of them. And if I go and inspect any one of these, I'm getting my structured data now. So I'm inside Datadog. I set up a data dictionary to say, this is what CMCD looks like. And I'm able to read the measured throughput, the buffer length, the bit rate, the download time, and the session ID from every request that's coming into my log files. So then on top of that, I wrote a number of charts and output variables here. So first of all, I can count the number of unique session IDs, and now I'm showing buffer length for my independent players, as well as bitrate being played, which was varying because I had throttled it. Now, I wouldn't do this if I had 100,000 players. I'm just showing it here so you can clearly see the two. But what I could do if I had a large population is draw heat maps and start setting triggers and thresholds of alarms. And I could easily detect an anomaly when something is going wrong in a certain area and either react to it from the CDN side, react to it from the customer side. So we're doing the full round trip from the players through the CDN back into a data analytics service here. So I think it's really exciting what we can start to do with CMCD. So how can you get involved? The spec's available here. It's free. It's royalty free. I encourage you to download it from that URL there. I made a tiny URL. There's a JavaScript reference implementation built in a dash.js. So go check that out in GitHub there. Realize are also providing an Exoplayer reference implementation along with a typing and formatting library. So if you want to put it in your player, you just give it the right attributes and it will format them correctly into the header or query arg strings for you. Akamai CDN, we already support the query arg transferal via our DataStream product. That's what I just demoed today. We have header support coming in 2021 as well if you want to send it in via headers. I encourage you to join CTA Wave Project so we can work on version 2. We're not going to do that next year. We'll get this into deployment first, but eventually there may be improvements we can make, and that'll be the home to do it. And then lastly, should there be common media server data? This has come up. We actually have a GitHub issue to track this. So if you think there's useful things a server or an origin can send to a CDN or to a player, for example, prefetching is another very useful hint there. So data flowing in the opposite direction, then again, join me and we'll see if we want to put a spec together for that. And with that, I conclude. I went just slightly over my 20 minutes here. I apologize for that. I really appreciate your interest and attendance today, and I'm always happy to answer any questions. Thank you. Cheers.